Welcome viewers. In this video we'll see the test performed on the single phase induction motor in order to draw the equivalent circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we go to the topic. To draw the equivalent circuit, we are going to perform the test on the induction motor, single phase induction motor. The following tests are conducted on single phase induction motor to draw the equivalent circuit. There are two tests we are going to perform: no load test or open circuit test, blocked rotor test or short circuit test. So the name itself is able to understand. It's a no load. Load is not applied. Second one, blocked rotor. Rotor is blocked. So first we will see the no load test. So the motor is run on no load. Load is not applied. Rated voltage is applied and readings of voltmeter, ammeter and wattmeters are noted. The circuit diagram is not given here, but the thing is we have to apply no load and wattmeter, ammeter, voltmeter is connected. We need to measure the value. The thing is rated voltage is applied. In case of blocked rotor test, rated current will be applied. Now we are applying rated voltage. So we are measuring voltage, voltmeter, ammeter and wattmeter reading. This refers no load voltage, no load current and no load power. V0, I0, W0. So W0 equal to V0, I0 cos pi naught. No load power equal to no load voltage, no load current into power factor at the no load. So from this we can find cos pi naught. That is, you brought this V0, I0 in the denominator. So omega naught divided by V0, I0 equal to cos pi naught. So cos pi naught equal to omega naught divided by V0, I0. That is nothing but no load power factor. So we are able to find the no load power factor from these three readings. No load speed is almost equal to the synchronous speed. No load speed means the motor is rotating at the synchronous speed. So therefore, for practical purpose, slip S can be assumed as 0. There is no slip. 1500 rpm means the motor will rotate at 1500 rpm itself at the no load condition. So the slip is 0. There is no slip. We know that there are two rotor circuit available: forward rotor circuit and backward rotor circuit. We are assuming the double field revolving theory in single phase induction motor. Based on double field revolving theory, forward circuit, rotor circuit and backward rotor circuit, both are rotating in opposite direction. Separate video available for the double field revolving theory. So based on that, for the forward rotor circuit we are assuming R2 by S. S equal to 0, so it becomes infinite. For backward rotor test, R2 divided by 2 minuses. We are taking 2 minuses. Here S equal to 0. So R2 divided by 2 is not S, R2 divided by 2. So forward circuit, the resistance is infinite. Backward circuit, the resistance is R2 divided by 2. Now we'll go for the further detail. In forward circuit, R2 by S plus JX2 get eliminated because it is infinite, it got eliminated. In backward circuit, X0 is higher than R2 divided by 2 plus JX2. Therefore, current tends to flow through the low impedance path. So X0 of the branch is eliminated. Right? So in the forward path, this R2 by S plus JX2 is eliminated. In the backward path, X0 is eliminated based on the condition what we discussed, R2 by 2 and infinite. Now we'll see the equivalent circuit based on this assumption. So this is applied voltage, no load voltage, no load current, R1 X1, that refers the stator resistance and stator reactance. So this one refers the forward rotor circuit, this one refers the backward rotor circuit. We then know that this X0 we are having, this R2 by S X2 is eliminated in this for a forward rotor circuit. For a backward rotor circuit, X0 is eliminated. The current is flowing through R2 by 2 X2. Right? So based on these two assumptions, we can further simplify the circuit. Circuit is redrawn. So I0 voltage V0, no load voltage and no load current, the stator R1 X1. This X0 based on the forward rotor circuit. R2 by 2 X2 is based on the backward rotor circuit. So what is available? It is Rotor. V0, I0, R1 X1 is X0, that is AB, under the point AB. Then R2 by 2 and X2. So all are connected in series. R1 X1, X0, R2 by 2 X2. Right? In that X0 is connected across AB. This network is connected across CD. So that is given. Stator, forward rotor circuit, backward rotor circuit. So V0 can be written as VAB. We will take this VAB, voltage across the forward rotor circuit. Then remaining R1 plus R2 by 2, R1 plus R2, resistive value, plus J, reactance value, X1 plus X2. So we can write that VAB, we will write VAB. So this term is brought that side, so negative. So VAB equal to V0 minus I0 of R1 plus R2 by 2 plus J X1 plus X2. Now we will find the VAB value. Our aim is to find the VAB value. So VAB equal to I0 X0. Voltage across that is voltage across is that no load voltage and X0 is flowing. V equal to I into R. So X0 equal to VAB by I0. We know that X0, small x0 equal to capital X0 divided by 2, because we have two rotor circuit, forward and backward. So it is exactly divided into 2, X0 by 2. From that X0, capital X0 equal to 2 times of small x0. This X0 is nothing but VAB by I0. So 2 into, substitute this, X0 equal to VAB by I0. So from there we are able to find X0 equal to 2 of VAB divided by I0. So we are able to find the X0 value by using the no load test. And then we'll go for the blocked rotor test. The another 2 parameter we can able to find from the blocked rotor test. So in that, rotor is held tight so that it does not rotate. Say that is a rotor is blocked. In previous test, the load is not applied. Now the load is applied. Rotor is held tight. It is fully blocked. Voltage is adjusted to apply the rated current. In previous case, we apply rated voltage. Because of short circuit, we apply rated current. The readings of voltmeter, ammeter and wattmeters are noted. Right, like previous case. In this case, here VSC, short circuit voltage, short circuit current and short circuit power. In previous case, no load voltage, no load current and no load power. But now it is blocked so that it refers the short circuit. Now based on that, we will see that the rotor is blocked. So N equal to 0, S equal to 1. Completely there is no speed. Fully slipped, S equal to 1. In previous case, the motor is rotating at the rated speed. So no slip, 0. All speed is equal to the rated speed. So there is no slip. No, speed is not slipped. But here the entire speed is slipped. That is speed is 0. So now we need to substitute the S value equal to 1. Previous case S equal to 0. So for forward rotor circuit we know that R2 by S. Now S equal to 1. So it is R2. For backward rotor circuit, R2 divided by 2 minus S. Now S equal to 1. So 2 minus 1, 1, R2. So for backward and forward both the circuit, the resistor value is R2. Here also R2. Now X0 is higher than the rotor impedance. So that is neglected. X0 is the higher than the rotor impedance. So that X0 value is not included here. So based on that we can draw the equivalent circuit. ISC, VSC, short circuit voltage, short circuit current. R1, X1 refers the stator resistance and stator impedance. Reactance, stator reactance. Then this X0 is neglected. X0 is higher than the rotor impedance, so it is neglected. Only we have this R2, X2. We already calculated for both the case R2, the value is R2. So R2 X2. So R2 plus R2, we here add the resistor value. R2 by plus R2 is 2R2. That is equal to capital R2. You know that small r2 equal to capital R2 divided by 2. So capital R2 equal to 2 times of small r2. So 2 into small r2 can be written as capital R2. Similarly, 2x2, small x2 can be written as capital X2. So now we calculated R2 value and X2 value. This X0 is neglected. These R2 are added together, the X2 are added together. Now we'll go for the further readings. So the short circuit power WSC equal to VSC ISC into cos pi SC. So from that cos pi SC can be written as WSC divided by VSC into ISC. Blocked rotor power factor. Earlier case no load power factor, now it is blocked rotor power factor. Z equivalent equal to VSC by RSC impedance. From the and R equivalent equal to WSC divided by I square. That is power equal to I square R. Power equal to I square into R. So that R equal to power divided by I square. So we are able to find the resistance, equivalent impedance. And we know that the R equivalent equal to R1 plus R2. So that R2 equal to R equivalent minus R1. From the rotor resistance referred to the stator. So we are able to find the R2 value. Then X equivalent equal to square root of Z equivalent minus R equivalent. This is a normal impedance formula. Right? Reactance equal to square root of impedance minus resistance. So assume that X1 equal to X2. So that X2 equal to X equivalent divided by 2 because both are equal. So now we calculated R equivalent, R2 value as well as X2 value. That is our aim. We need to find the R2 and X2 value. In the previous test, no load test, we calculated X0. Here we are calculating R2 and X2. R1 AC equal to 1.5 times of R1 DC. That is referring AC and DC circuit. In case of AC and DC, this is the relation. So in this video, we discussed the test performed on the single phase induction motor, no load and blocked rotor test. From no load means the load is not applied, motor rotating at rated speed, slip equal to 0. Based on that, we can measure no load current, no load voltage, no load power. From that we can find no load power factor. Finally, we calculated X0 value. In blocked rotor test, the rotor is completely blocked, speed is 0, so slip equal to 1. That is substituted. We are able to measure short circuit current, short circuit voltage and short circuit power. Then finally we calculated R2 value and X2 value. So by using this parameter, we are able to draw the equivalent circuit of a single phase induction motor. The explanation of equivalent circuits, separate video available. The link is given in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.